Welcome to the Deep Dive, the place where we take complex, cutting-edge source materials, the kind of information that often gets locked away in private repos or conference talks, and distill the most valuable architectural insights directly for you, our perpetually curious learner.
Today, we are analyzing really a monumental achievement in AI development infrastructure. We're talking about a 6-month battle-tested reference library designed specifically to transform an AI coding assistant, in this case Claude Code,
Right.
from a passive dictionary that you have to manually consult
Mm.
into an integrated proactive partner that anticipates your needs, enforces standards, and actually scales with your project.
And if you've spent any time working with these incredible tools, you know the frustration. I mean, they're brilliant. They're capable of writing code far faster than we can, but their knowledge, their specialized skills, they often feel, I don't know, locked away.
Inaccessible.
Yeah, exactly. You're in the middle of a flow, you're tackling a tough bug, and you know there's a specific internal guideline for this exact scenario, but you have to stop, remember the slash command, type it in.
And hope you get it exactly right.
Right. And then you pray you didn't just hit a context limit in the process and get a useless answer.
That is the core frustration. I mean, the source material frames it perfectly. It says AI skills often just sit there, passive, and just waiting for manual instruction. This deep dive is into the specific infrastructure that solved that enterprise-level scaling problem.
And this wasn't just a thought experiment.
Oh, not at all. This was extracted from managing a high-complexity TypeScript microservices project. This wasn't theoretical R&D. This was R&D born of necessity, of solving real scaling and consistency issues across multiple development teams.
So our mission for you is to give you a shortcut to understanding the 3 specific architectural breakthroughs that make this whole system work. We'll be detailing the essential components, the hooks that enable autonomy, the modular patterns that conquer those context limits we just talked about.
And the specialized agents that streamline the really complex tasks. You are walking away with 6 months of high-level architectural knowledge compressed into a single focused session. Okay, let's unpack this. Starting with what the sources repeatedly call the central breakthrough, the system that allows skills to activate themselves. Okay, so let's start with that fundamental pain point again, manual invocation. You're trying to quickly add a new endpoint, and you have to adhere to a very specific internal repository pattern, right?
Right.
And so you have to stop your coding momentum, your flow state, to manually type callback end dev guidelines. It's disruptive.
It completely breaks your concentration.
Yeah.
And this infrastructure, it solves that. The source material rightly highlights this auto activation as, the killer feature.
So how does it work? Because it sounds like magic.
It really does feel like it, but it fundamentally changes the developer experience. It takes the AI from being a passive knowledge base and elevates it to an active collie, a silent guardrail that's constantly monitoring your work.
And the mechanism is, well, it's fascinating because its power comes from the strategic application of some pretty simple components.
And what are those components?
Well, it really relies on a collaboration between 2 key elements. You have the operational mechanism, which is a specialized piece of code called a hook, and then you have the knowledge base that informs it, which is the configuration file.
Let's define a hook in this context. I think most developers hear hook and they immediately think of like Git hooks or web hooks. Is this the same kind of thing?
That's a really necessary clarification. It's similar in concept, but different in application. In this system, a hook is a script or a function that's integrated deeply into the AI environment itself. It sits at a specific predefined point in the workflow, the whole processing pipeline, and it intercepts the data flowing through.
So it's like a custom plugin.
Exactly. Think of it as a custom software plugin that triggers based on a very specific event.
Okay, so what's the crucial event here? What makes the auto activation actually happen?
The first core component is the skill activation prompt hook. And crucially, its type is UserPromptSubmit. This is the key.
UserPromptSubmit. So that means...
It means that the hook fires every single time the user sends a query to the AI, but, and this is the important part, before that query reaches the large language model for generation, it's an immediate pre-processing step.
Okay, so it intercepts the user's intent before the model even starts thinking. It gets a first look at the data flowing in.
Exactly. And the second half of the equation is where the intelligence lies. The configuration file, skillrules.json. This is where the development team has codified all the trigger patterns.
The rulebook.
The rulebook, precisely. It's a formalized structure that maps specific contexts, keywords, prompt phrases, or even file paths to specific skills.
Okay, so let's visualize the workflow. Walk me through it. I'm editing a file in my project, maybe in the services directory, and I type a prompt like, I need to ensure robust input validation for the new user creation function. What happens next?
Okay, so in the blink of an eye, 4 things happen. Step 1, you submit your prompt.
Yes.
Step 2, the skill activation prompt hook immediately intercepts that prompt because it's a UserPromptSubmit type. Step 3, the hook then checks the skill rules.json file, and it's looking at 2 crucial pieces of information at the same time. The text of your prompt, it sees words like validation, user creation, and it looks at your current file context, so it sees the path services.
So it knows what I'm asking and where I'm asking it from.
Exactly. And then step 4, if that rulebook has a rule that says if the prompt mentions validation and the user's in a service file, then they probably need the backend dev guidelines. The system automatically and silently injects that skills knowledge into the context for that single query.
Wow, that is a fundamental change in the entire interaction model. The developer no longer has to remember the rule. The architecture remembers it for them.
Yes.
It's a massive reduction in cognitive load. It turns what was an act of memory into, well, architectural automation.
And this automation is so critical that the source material identifies 2 essential hooks for what they call phase 1 integration, meaning if you do nothing else, you have to implement these 2 to start getting value.
Okay, so we know the first one is skill activation prompt. That's the engine. What's the second one? Post tool use tracker. Why is that considered non-negotiable right at the start?
So the post tool use tracker is a different type of hook. Its type is post tool use. This means it fires after the AI assistant has finished executing a tool or a skill.
Okay, so one is pre-processing, this one is post-processing.
Exactly. While skill activation prompt manages the input and the proactivity, the post-tool use tracker manages accountability and feedback.
Accountability, how so?
Well, think about it from an enterprise environment. A team lead or a manager needs to know, are these expensive, custom-built guardrails we spent weeks on actually being used?
Right, is this thing paying for itself?
Is it making a measurable impact? Is the back-end dev guideline skill actually reducing bugs or improving compliance? This hook tracks that utilization, it logs the outcomes, and it helps the development team refine the rules in skill-rules.json. It closes the loop.
I see, so it's not a black box. It turns the AI tool into a measurable part of the CI/CD pipeline.
You got it. And the force assures us that these 2, the proactive activation mechanism and the feedback loop mechanism, they were pretty much out of the box with virtually no customization needed for that first phase.
That's the guarantee for phase 1.
That's the guarantee. They provide the core magic immediately. This is the architecture shifting the AI tool from being, like you said, a dictionary that you have to look up to an active development guardrail that enforces consistency and best practices automatically.
So if your standard says every repository file has to have a specific structure,
The moment a developer touches a file in the repository directory, the AI is instantly armed with that knowledge. It ensures compliance without the developer ever having to open the internal wiki.
that's incredibly powerful. It solves the proactivity problem. But I can immediately see the next issue. You start adding dozens of these new automated guardrails, rich with all this comprehensive documentation, and that introduces the next nightmare, which is, of course, context limits. How did this architecture handle that scaling failure?
You've absolutely hit on the critical, immediate follow-up challenge. It happens to everyone. You create these brilliant, comprehensive skills, say a 5,000-line documentation set detailing every security protocol, every database migration rule, every API spec.
The ultimate source of truth.
Exactly. And you load it. And suddenly, 80% of the model's working memory, this context window, is consumed by that documentation before it even sees the 50 lines of code you actually asked it to review.
And it just chokes. It runs out of steam and gives you a generic, useless answer because it has no room left to think.
It's the paradox of knowledge, right? The richer the knowledge base you give it, the less working memory the AI has for the actual task at hand.
So what's the solution?
The solution, which apparently took months to perfect, is called the modular skills pattern. It's a pattern designed around intelligent resource management, and it's governed by 2 key principles, the 500-line rule and a concept called progressive disclosure.
Okay, let's start with that 500-line rule. That sounds incredibly specific. Why 500 lines? Why not 450 or 600?
Yeah, and it's not arbitrary. It's a practical optimization that they derived from those 6 months of heavy testing. The architecture dictates that the main entry point for any skill, the skill.md file, has to be concise. It must be under 500 lines.
So it's like a briefing document.
Think of the skill.md file as the index card on a library shelf. It tells the AI what the skill covers and, more importantly, where to find the deep dive information. It's the table of contents.
So if the core document is just the table of contents, where is the actual, the heavy documentation stored?
That's where progressive disclosure comes in. And this is, I think, the genius architectural decision. All the deep dive resources, the actual security protocols, the specific API specifications, the step-by-step testing methodologies are all split into separate files.
Okay.
They reside in a subdirectory, usually named resources, with files like resources.-1.md or resources database-layer.md, and so on.
And I'm guessing the critical rule applies here too.
Critically, yes. Each of those individual resource files is also kept under 500 lines.
Wait a minute. So the effective knowledge base could be 10, 20 times larger than what the model initially sees. That's a huge architectural leap just to save context space. How does the system manage that flow? How does it know which resource to load?
So the flow is intelligent. When the skill activation prompt fires, or even when you manually call a skill, the AI only loads the main concise skill.md file. That's it. It reads the overview. Then, when you ask a specific granular question, for example, okay, I'm implementing a new rate limiter. How should I handle the distributed caching for it? The AI looks at that 300-line index card. It sees that the answer is likely contained in a file called resources-distributed-caching.md.
And only then does it load that one specific file.
Only then does it incrementally load that specific, small 450-line resource file into its context.
That's just its intelligent resource management. It means the model's capacity isn't clogged up with irrelevant details about, say, front-end component styling when I'm asking about back-end routing.
Exactly. It loads what it absolutely needs precisely when it needs it. A just-in-time context model.
And the source material has examples of this, right?
Oh, yeah. And we can see this pattern beautifully in the project examples.
Yeah.
Take the back-end dev guideline skill. The main file is only 304 lines long, and it just serves as a navigation guide. Yet, it is supported by a staggering 12 resource files. 12. And these resources cover the full stack of back-end development. Routing conventions, specific controller logic structure, service layer patterns, repository guidelines, database connection pooling, everything you'd need.
So it's a full technical library delivered in these bite-sized, context-safe chunks. I assume the same applies to the front-end guidelines?
Absolutely. The front-end dev guidelines skill is 398 lines in the main file, and it's supported by 11 resource files. This might include specific guidelines on React hook usage, accessibility rules, MUI v7 component overrides, or the team's state management philosophy. The developer gets comprehensive guidance without ever overloading the model's context. This modularity is how the architecture scales effectively.
Okay, so that's brilliant. Modular skills conquer the context limit associated with loading knowledge, but we have to address the other major, incredibly painful context problem. The context reset.
Ugh, the worst.
Every developer listening knows that gut punch feeling. You've had a great 45-minute architectural conversation with your AI partner. You've made key to sevens, you've reviewed compromises, you've mapped out a complex plan, and you come back after lunch, and bam.
Context reset. It's gone.
All that specialized, hard-earned project knowledge is just gone. The AI has amnesia.
And that amnesia is a devastating project killer. It's a natural failure point of the current generation of AI tools. You waste hours just reestablishing the historical decisions and architectural compromises that were just made a few hours ago.
So how did this infrastructure solve that?
It developed a solution called the DevDocs pattern, which is, I think, one of the most significant architectural advancements in the whole library.
The DevDocs pattern. So what is it?
At its core, it's a /command, DevDocs, that generates a structured 3-file system for preserving the state of a long-running task.
Wait a minute. Isn't this just another way of saying, write more documentation? I mean, how is forcing the AI to generate those 3 structured files truly better than a developer simply copying and pasting the conversation into a standard Markdown file? We're all dealing with documentation fatigue as it is.
That's a fair challenge, and it really hits on why the structure is so paramount here. Standard documentation that a human might write is often unstructured, it's verbose, and it's difficult for an AI to parse quickly for context restoration. The DevDocs pattern forces the capture of information into 3 highly formalized files that are specifically optimized for AI consumption.
Okay, so tell us what those 3 files are and how their structure makes them instantly consumable by the AI.
All right, file number 1 is taskplan.md. This is the strategic overview. It captures the high-level vision, the why, and the what of the feature being developed. It's always concise and focused on the objective. We are building a new user authentication endpoint to support OAuth 2.0.
The mission statement.
Exactly. File 2 is taskcontext.md. This is the key decision log. This file captures all the key decisions made during the conversation, the specific architectural compromises, the files that were touched, and the reasons a particular approach was chosen over another. We chose to use passport.js instead of a custom solution because of X, Y, and Z.
So it preserves the historical rationale.
Right. Because it's a dedicated decision log, the AI knows exactly where to look to restore the why of the project.
And the third file.
File 3 is tasks.md. This is the simplest one. It's just a checklist format, the concrete action items remaining. It's designed to be immediately actionable for both the developer and the AI.
Ah, I see the difference now. If the context resets, the developer doesn't have to spend an hour trying to re-explain the last 5 hours of work. They just use a simple command, probably deb-docs update or something,
Exactly.
which points the AI to those 3 structured files. All the historical rationale and architectural decisions are instantly restored because the format is optimized for retrieval.
Precisely. It turns the transient nature of an AI conversation into persistent, structured project knowledge. It shifts the burden of memory from the AI's limited context window to the repository's structured documentation. It's the core mechanism that allows complex development tasks to span days or even weeks without losing the plot.
A huge improvement for long-running features.
A massive one.
That structural persistence is genuinely transformative, and it transitions us perfectly into the full array of specialized tools this infrastructure provides. It's not just a set of fixes, it's a robust toolkit. So we've established the core mechanics, right? Auto-activation via hooks, and context management via the 500-line rule. Now let's look at the actual tools, the skills and agents that deliver that specialized value. But before we dive into the specific tools, we need to clarify the difference. What's a skill versus an agent in this architecture?
Yeah, that differentiation is vital. In simple terms, a skill is a modular knowledge base. It's pure documentation and structured guardrails designed to inform the AI model's response. It tells the AI what the rules are.
Okay, the reference library.
Right. An agent, however, is typically a pre-baked, highly optimized system prompt that gives the AI a specific role, a specific authority, and a mandate for a single complex job. It tells the AI how to behave and what its goal is.
So, skills are the library. Agents are the specialized consultants you hire for a specific task.
That's a perfect analogy. Let's start with the 5 production skills, as these are the knowledge bases that follow that modular pattern we just discussed.
The first one, skill developer, sounds almost meta.
It is. At 426 lines, the skill developer is a meta skill. Its specific function is to serve as the blueprint and the toolset for creating and managing other skills.
Wait, really?
Yes. So if your organization introduces a brand new security protocol, say a new standard for dependency injection, you don't manually write the skill.md from scratch. You use the skill developer skill to help the AI generate the new modular documentation, ensuring it follows the 500-line rule and the progressive disclosure structure right from the start.
That's amazing. So it's the AI's self-governance tool. It means the system is self-aware enough to help automate the scaling of its own rulebook.
Exactly. Then you have the 2 core domain skills, the day-to-day development guardrails, back-end dev guidelines at 304 lines, and front-end dev guidelines at 398 lines. These are the most critical for ensuring consistency.
What kind of stuff is in those?
Well, the back-end skill focuses on specific stack patterns, how to integrate Express middleware correctly, the required Prisma schema definitions, and the specific Sentry logging patterns that have to be used across all the microservices. The front-end counterpart dictates React component structure, the adoption rules for MUI v7, and very strict TypeScript usage.
So they're there to make sure all 6 microservices follow the exact same architectural conventions, no drift.
Zero drift. And the final 2 skills, they solve specific production-critical pain points. They really drill down into operational concerns. You have Route Tester, which is 389 lines, and is highly specialized for testing authenticated API routes. In a microservices architecture, especially one with complex authentication flows, manually setting up route tests is a recurring nightmare.
Oh, I know that pain well.
So this skill guides the developer and the AI on exactly how to structure secure, reliable, and repeatable tests for those endpoints.
And the last skill.
And finally, error tracking, which is around 250 lines. This provides detailed Sentry integration patterns. So when an error pops up in production, the AI, armed with this skill, knows exactly how the logs are structured, how exceptions are captured, and what the established process is for triage and resolution.
The level of detail here just shows this infrastructure wasn't built for some hobby project. This was built to survive enterprise reality.
Hmm.
Now let's shift to the agents. The source material notes there are 10 of them, and they're described as standalone, just copy and use. These seem designed to tackle one complex task with maximum focus.
Yes. Agents are where that specific job authority comes in. They streamline tasks that usually require a senior developer to spend hours or even days defining the scope and structure. They automate high-level intellectual labor.
So give us a detailed look at the roster. Why are these 10 specializations necessary? Let's start with the ones focused on quality and architecture.
All right. First, there's the code architecture reviewer. In a project with 6 microservices and 50,000 lines of code, architectural drift is inevitable. A developer fixes a bug in service A using a pattern that, subtly violates the rule used in service B.
The small inconsistencies that add up to a huge mess over time.
Right. So the code architecture reviewer agent is given the authority to review a pull request, not just for syntactic bugs, but for adherence to those defined cross-service architectural consistency patterns outlined in the backend dev guideline skill. It's an automated gatekeeper for architectural integrity.
That's phenomenal. It basically replaces those endless, high-bandwidth peer review meetings that are focused solely on structural consistency.
Precisely. Then you have the code refactor master. Refactoring is risky, it's complex. A developer might change a function signature and unknowingly break dozens of dependent files across the codebase.
A nightmare scenario.
This agent is specialized to plan and execute those complex, large-scale refactoring projects. Its system prompt dictates a very structured approach. First, dependency mapping. Second, planning the phase changes. Third, executing the changes and generating the necessary test updates. It manages the risk and coordinates the sweeping changes.
So these agents sound like they replace a senior developer spending a whole day just writing a comprehensive refactoring or migration plan.
They absolutely do.
Yeah.
We also see specialized documentation support, going beyond even the DevDocs pattern. There's the documentation architect. This agent is tailored to generate comprehensive, external-facing documentation, likely leveraging and aggregating the structured outputs from the DevDocs pattern and the modular skills. It ensures that your user-facing documentation is always consistent with the internal guardrails.
And what about for operational debugging?
For that, 2 agents really stand out. The author-out debugger is specific to a universal developer pain, authentication issues.
Oh, definitely.
They are notoriously tricky because they often involve cross-cutting concerns, tokens, middleware, specific header requirements. This agent is given a specific mandate to focus only on that complex intersection of routing and security, which dramatically speeds up diagnosis time.
I can see that being a lifesaver. And what about the agent aims squarely at just improving developer velocity and eliminating common roadblocks?
That would be the auto error resolver. Its system prompt is likely tuned to identify, analyze, and then automatically fix common TypeScript errors. In a large, complex TypeScript codebase, especially when you're dealing with external libraries or new dependency upgrades, just chasing down type errors can consume hours of a developer's week.
It's tedious, frustrating work.
This agent automates that tedious cleanup, allowing developers to focus on feature logic and business value, maximizing that flow state we talked about.
The breadth here is really impressive, from high-level architecture review all the way down to the nitty-gritty of error resolution. We've covered skills and agents. Let's briefly finish this section by reviewing the remaining automation tools, the full set of hooks, and the final / commands.
So we already identified the 2 essential hooks for phase 1, scale activation prompt and post-tool use tracker. But the source details 6 hooks in total, which means there were 4 optional ones. These are focused more on build and error stoppage mechanisms.
Okay, let's talk about the risk associated with those optional build hooks. They sound a little more dangerous.
They can be. They include scripts like tsccheck.sheesh and triggerbuild-resolver.she. And the source material gives a crucial warning here. These optional hooks, which typically run during the build process or as pre-commit or pre-push checks.
Like a Git hook?
Exactly like a Git hook. They require heavy customization. They are intrinsically tied to the original project's physical file structure.
What kind of file structure are we talking about?
They reference specific service names and monorepo directory layouts. For example, a script might contain a hard-coded reference, like cd services blog appy and npm, run tsc.
Oh, I see the problem.
If the listener's project doesn't have a services blog appy directory, that hook will break their build or their pre-commit process immediately upon installation.
That's the landmine we have to warn you, the learner, about. The core activation hooks are plug and play. These build-stop hooks are environment-specific and require surgical adaptation.
Absolutely. And then quickly we have the 3/ commands, which just reinforce the documentation and context management themes. We already detailed DevDocs, which initiates that structured 3-file documentation capture.
And the other two?
The other two are straightforward. DevDocs update, which you'd use to incrementally update those strategic files just before you take a break or expect a context reset, and route research for testing. This one likely tells the AI to specifically analyze API route patterns within the code base for the purpose of test setup, leveraging that route tester skill we mentioned.
This whole catalog just demonstrates that this isn't a basic integration. It's a fully operational system built for robustness, consistency, and scale. Let's now pivot to validating that robustness, the real-world proof. So the core value proposition here, what makes this so compelling, is the production-tested patterns assurance. These weren't just theoretical concepts cooked up in a lab. They are the solutions to real, daily, enterprise-level production problems.
That validation is everything. And the sources, they quantify the scale of the original project these patterns were extracted from, which tells us exactly what kind of pressure cooker this architecture was refined in.
Okay, let's quantify that pressure. What were the specifics of the project? What kind of environment are we talking about?
We're talking about a substantial, complex environment. There were 6 distinct microservices that were already running in production. The sheer scale of the code base was over 50,000 lines of TypeScript code. And on the front end, they were managing a React application featuring complex, high data volume data grids, which, as you know, are a known source of performance and state management complexity.
Absolutely. And managing 6 microservices, that means you're dealing with dependency hell, you're dealing with versioning issues, and you have to ensure consistent inter-service communication protocols. That's a highly pressurized environment.
It is. I mean, if you're managing 6 services, the friction points are everywhere. It's dependencies, it's API version skew, it's maintaining identical security practices across all 6 independent deployments. A failure inconsistency in one service could cascade and take down the entire system.
So that's why the architectural guardrails, powered by these auto-activating skills, were so mission-critical.
They had to be. And the final metric of validation is perhaps the most important. 6 months of daily Claude Code use under these demanding real-world conditions.
6 months of daily heavy pressure testing. That validates that the hooks don't fail, the modular structure holds up, and the specialized agents actually deliver reliable, complex output consistently.
It validates that the system survives architectural evolution and the technical debt management that's inherent in any living enterprise project.
Yeah.
They solve the problems of scaling knowledge and enforcing consistency in a truly production setting.
Okay, so now let's turn to the practical side. Despite the system taking 6 months of R&D to build, the source material promises a remarkably fast setup guide. It estimates a total integration time of only 15 to 30 minutes for initial functionality. How is that even possible?
That speed is the immense benefit of adopting a reference library like this. You are copying proven, working solutions, not building custom architecture from the ground up. The recommended approach is a clear, 4-phase workflow designed for minimal disruption and fast value realization.
So walk us through phase 1, that critical phase where we get the auto-activation engine up and running.
Okay, phase 1, skill activation. Estimated time, 15 minutes. This is the foundation. The developer must copy the 2 essential hooks, skill activation prompt, and post tool use tracker into their environment.
Just copy the files.
Just copy the 2 files. After that, they simply update their project's core configuration file, settings.json, to reference these new hooks. And that's it. If you stop right there, you have fundamentally enabled auto-activation and feedback logging. The machine is now proactive.
Okay, 15 minutes to a proactive AI. Phase 2 is about loading the initial knowledge base using that modular pattern.
Right. Phase 2, add first skill. Estimated time, 10 minutes. Here, the developer should pick one highly relevant skill from the catalog, let's say the back-end dev guidelines. They copy the entire modular skill directory, which includes the main 304-line skill.md and all 12 of its resource files, into their AI configuration structure.
So what's in that directory besides the markdown files?
Mostly just the markdown files, structured in that main file plus resources subfolder pattern. But then comes the crucial part. They must then create or update the skillrules.json configuration file. This is not a simple copy.
This is where you have to do some thinking.
This is where they map the skill's trigger rules to their own project's specific file system structure. The skill needs to know. If the user is asking about routing and the file path is Sugepa routes, activate. The rules have to be adapted to the listener's project structure.
I imagine this phase is where that small time estimate might stretch a bit if you, the learner, have a highly unconventional repository layout.
It might, but the process is structured. You just map the patterns. If the architecture is reasonably standard, 10 minutes is achievable.
And phase 3 is the essential validation loop. You can't skip this.
Phase 3, test and iterate. Estimated time, 5 minutes. This is non-negotiable. The developer must test the loop. They edit a file that's relevant to the skill they just installed, say a controller file, and they ask a question that should trigger the skill. They verify that the suggestion engine works, that the skill activates, and then they verify the AI's response actually uses the information contained in the skill. This rapid loop ensures the setup is correct before moving on.
And then phase 4 covers the ongoing optimization and customization, which is where the risk lives.
Yes. Phase 4, optional enhancements. This is where the developer adds the specialized agents, implements the slash commands, or for those with sophisticated CI/CD pipelines, attempts to integrate and customize those advanced optional stop hooks.
We absolutely need to stress that customization risk. The source material provides critical warnings about what will not work as is. Ignoring these warnings turns a 15-minute integration into a week of debugging.
We cannot stress this enough. The source material contains a landmine you must avoid. The provided settings.json file is explicitly an example only. If you copy that example wholesale, you will immediately break your local environment or your build pipeline.
Why?
Because those optional stop hooks reference specific service names and a monorepo structure you likely do not possess. It will just fail.
So you, the learner, must be surgically precise when implementing phase 1 and 4.
Absolutely. You must extract only the 2 essential UserPromptSubmit and post-tool-use hooks for that initial activation. The optional stop hooks must be ignored, customized, or removed entirely if they reference specific service directories like blog API that won't exist in your setup.
And there's a second major warning, and it relates to the content of the skills themselves.
Right. The skills use these generic blog domain examples, post, comment, and user entities as teaching illustrations. The source is very direct about this. These are simply vehicles for conveying the architectural pattern.
So you have to look past the content to the structure.
You have to look past the blog post examples and adapt the underlying pattern, the structure of a repository, the logic flow of a service, to your own business logic, whether you are building an e-commerce platform, a financial application, or a SaaS product. The value is in the modular infrastructure, not the example content.
This really emphasizes that what we're diving into is architecture, not just boilerplate code.
Precisely. And one final structural warning. If you do choose to use those complex optional hooks like tse-check.esh, they expect specific service directories to exist. You will need to customize the shell scripts themselves to match your own project layout. If you don't have a monorepo, you probably won't need them at all. But if you do, ignore the path references at your peril.
That's excellent context. We have covered the architectural breakthroughs, the specialized toolkit, and the practical path to implementation, complete with the essential warnings. Let's wrap up with the core value proposition this infrastructure delivers. #TechTag outro. So to summarize all this infrastructure really represents a fundamental, production-validated shift in how developers interact with their AI assistants. We move the developer from a state of frustration and inefficiency to a state of true augmentation and automated governance.
The before picture is one of friction, right? It's manual invocation, it's skills often failing because you hit a context limit, and it's that dread of context resets wiping out historical knowledge, which inevitably leads to inconsistent development patterns across a large team.
But the after picture, the state that this production-tested library enables, is a system where the AI truly acts as an active, consistent partner.
Right. After integration, skills suggest themselves based on file and prompt context, and that's thanks to the autonomous hooks and the skill rules.json. The modular skills, governed by the 500-line rule, ensure that your knowledge base can be incredibly deep, but never overwhelms the model's context capacity, solving that scaling challenge.
And the dev docs.
And critically, the DevDocs pattern preserves high-level decisions across context resets, turning those transient AI conversations into persistent, structured records. And finally, the specialized agents streamline complex, multi-step tasks, automating specialized developer labor.
For you, the learner, let's distill this into the 3 most important architectural takeaways you should carry forward into your own project.
Okay, takeaway number 1. The power of hooks combined with configuration, skill rules.json, to create autonomous AI interaction. This is the engine of proactivity. The core insight is making the AI act like an active colleague, not a static book, by giving it access to the workflow at the pre-prompt stage.
Takeaway number 2.
Takeaway number 2. The architectural necessity of the 500-line rule and progressive disclosure. This is the essential scalability solution. It lets your skills be infinitely deep without hitting model context limits. It's intelligent, context-safe knowledge management through modularity.
And the third and final key takeaway.
And finally, takeaway number 3, the DevDocs pattern, that simple 3-file structure, for turning those transient AI conversations into persistent, actionable project knowledge. This solves the amnesia problem inherent in long-form AI development and ensures your complex decisions are preserved, restorable, and searchable.
Fantastic. So if these production-tested patterns, the hooks, the modular skills, the specialized agents, if they were born for managing just 6 microservices and 50,000 lines of code, solving consistency and context management at that scale, what are the implications of this modular auto-activating architecture for companies managing dozens or even hundreds of services? The vision of scaling automated guardrails is just enormous.
It really suggests that the future of large-scale software development might look a lot less like manual policy review and more like automated architectural police.
And this leads us to our final provocative thought for you to explore. Given the existence of that skill developer meta skill, a tool explicitly designed for creating and managing other skills, what future role will this specific tool play in automating the creation of AI guardrails themselves? Could the AI, over time, learn new development standards or detect architectural drift, and then use the skill developer to autonomously write and deploy the new modular guardrails, effectively enabling a fully self-managing knowledge base without constant manual input from human developers?
The AI not just coding, but policing its own compliance. It's something to consider as you start copying those 2 essential hooks for your phase 1.
That's it for this deep dive. Thank you for joining us, and we look forward to seeing you next time.